Okay, here we have 15G, and given two lines we need to use vector methods to find where these lines meet. Now this is, of course, a 2D problem. So these lines will meet somewhere either or they're of course parallel. So let's set up the vector equations. The x-coordinates need to be the same and the y-coordinates need to be the same. And with x-coordinates I mean any point on this line, the x-coordinate of that point will be -2 plus 3s. And for the other line, the x-coordinate of any point on the line will be 15 take 4t. The y-coordinates will be 1 plus 2s respectively and 5 plus t. Now if we clean this up and we bring the t's and the s's to the left and the numbers to the right, we can say it's 3s plus 4t equals 17, and for the y-coordinates it is 2s take t equals 4. Now this is a system of equations with two unknowns, two equations, two unknowns. So we can easily solve this by hand, and we could say to multiply this equation by 2, and we could multiply this equation by 3, and after that we would subtract the equations. So let's do that. So we have 2 times 3s, that's 6s, and then it's 8t and 34, and here we would get 6s and then -3t and 12. And now we subtract, and that of course will be cancelled out. 8t take -3t is 11t. 34 take 12 is also known as 22. Hence t is 2. Now if we plug in that t equals 2 over here in this equation, we could say, okay, 2s take 2 equals 4, therefore 2s equals 6, s equals 3. And now we have a choice. Either we use this t equals 2 and we substitute it in this line here for t obviously, or we could use the s equals 3 and substitute it in that line there, and the answer should be the same. So let's do it. T equals 2, that means 15 plus 2 times -4, and so that's a vector xy, and 5 plus 2 times 1. So it's 15 take 8, 7, 5 and 2 is 7. So the point, let's call it S, is 7, 7. If we chosen the red one, we would get xy equals -2 plus 3 times 3 and 1 plus 3 times 2, which is also 7, 7. So again, S, the point of intersection, is 7, 7.